Bismillahirrahmanirrahim. Assalamu Alaikum, dear student. Welcome to my YouTube channel Learn with Azam. Today we will discuss about new syllabus National Book Foundation Physics SSC 2 Unit number 14 Current Electricity. SLO base according to FBISC requirement numerical problems question number 5 to 8 National Book Foundation in part 2. So in question number 5 given statement of numerical problem is this. In given statement, question number 5, you are given three resistors. Here 5 kilo ohm, 10 kilo ohm and 15 kilo ohm. You are asked to connect their in different possible combination. Find the greatest and smallest resistance you can obtain by connecting them together. So, according to given statement, first of all, understand the question. According to understanding, here three resistors are given. One is 5 kilo ohm, second is 10 kilo ohm, and third is 15 kilo ohm. So we can find the greatest and smallest resistance. So greatest and smallest equivalent resistance we can combine by two combination. Here one combination is parallel and other is series. First of all, according to the statement, write the given data. In given data, resistor R1 is equal to 5 kilo ohm. 5 kilo ohm is equal to 5 multiplied by 10 raised to power 3 ohm. Here 1 kilo is equal to 10 raised to power 3. So resistor R2 that is equal to 10 kilo ohm. 10 kilo ohm is equal to 10 multiplied by 10 raised to power 3 ohm. And resistor R3 is equal to 15 kilo ohm. 15 kilo ohm is equal to 15 multiplied by 10 raised to power 3 ohm. Now we can find that the resistance, maximum resistance R maximum and resistance minimum resistance that is R minimum. So we can using the formulas in series combination. Equivalent resistance R equivalent is equal to R1 plus R2 plus R3 and in parallel combination the resistance of equivalent resistance 1 upon R equivalent is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. Now we can find the solution. In given solution, according to the statement, find the maximum and minimum values. Now, first of all, two possible combination in series and parallel combination. Now we use the in series combination the equivalent resistance R EQ is equal to R1 plus R2 plus R3. Now combine three resistance 5 plus 10 plus 15 answer is 30 kilo ohm. 30 kilo ohm is a maximum resistance. So in series combination the given resistance is maximum that will be equal to 30 kilo ohm. Now in a parallel combination we can find that the resistance of equivalent resistance that is equal to 1 upon Req is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3 is equal to 1 upon 5 plus 1 upon 10 plus 1 upon 15. Taking the LCM, so LCM is 30. So we have taking the values 5, 6 are 30, so 6 plus 3 plus 2. Now adding 6 plus 3 plus 2 is equal to 11. So 1 upon R equivalent is equal to 11 by 30. Now taking the reciprocal on both sides, so R equivalent is equal to R minimum, that will be equal to 30 divided by 11. 30 divided by 11 is equal to 2.72 kilo ohm. So in a series combination, maximum resistance is given that R maximum is equal to 30 kilo ohm, and in a parallel combination, given resistance is minimum resistance, that is equal to 2.72 kilo ohm. Now we will move the question number 6. In question number 6, given statement, two resistors of 20 ohm and 40 ohm are connecting in series with the battery of 50 volt. Find the current and power of each capacitor, and find the current and power of each resistance when they are connecting in parallel. So here two resistors are given, that resistance is 20 ohm and 40 ohm, and battery with connecting with the 50 volt. So we can find the current and power in both combination. Here series combination and also find in parallel combination. So according to the given statement, write the given data. In given data, resistance R1 is equal to 20 and R2 is equal to 40 ohm. Now the voltage of battery V is equal to 50 volt. Now we can require that, so we write that to find in a current in series I1 and in a power P1 and power P2. Similarly, in a parallel combination, current I, power P1 and power P2. So we have using the formula according to the statement, in a series equivalent resistance R equivalent is equal to R1 plus R2, and according to Ohm law V is equal to IR. Then in a power P is equal to I square R. Now in a other combination, in parallel combination, equivalent resistance 1 upon R equivalent is equal to 1 upon R1 plus 1 upon R2, and according to Ohm's law V is equal to IR and power P is equal to I square R. Now we using the formulas and calculate the current in series and parallel, and also find the power. Now we will move the solution. In solution numerical problem 6 is given that in a series combination, R equivalent is equal to R1 plus R2. The value of R1 is 20 plus value of R2 is 40. 20 plus 40, that is equal to 60 ohm. And now we can, using the Ohm's law, according to Ohm's law V is equal to IR. This implies that I is equal to V upon R equivalent. So 50 divided by 60. So current is equal to 0.8333 ampere, and in a power we can calculate the power P is equal to I square R. This implies that equal to IR. Here this implies that I is equal to V upon R equivalent, that is equal to 50 divided by 60. Now 50 divided by 60, that is equal to 0.833 ampere. Now we can find the power. In power P is equal to I square R. So we can find the power P1 is equal to I square R1. So the value of power P1 is equal to 0.833 whole square multiplied by 20. Now taking the square of 0.833, then multiply by 20. So power P1 is equal to 0.693 multiplied by 20. So the power P1 is equal to 13.87 watt. Now we can calculate the power P2. P2 is equal to I square R2. Putting the value of I, that is 0.833 whole square multiplied by 40. Now we can calculate the power P2 is equal to 0.639 multiplied by 40. So power P2 is equal to 27.7 watt. Now in parallel combination, given resistance is 1 upon R equivalent, that is equal to 1 upon R1 plus 1 upon R2. Here we can putting the values and calculate the resistance. Now we can calculate the current. So we have, according to Ohm's law. Ohm's law states that V is equal to IR. In parallel combination, current will be distribute and change R1 and R2, and voltage will be same. So current I1 is equal to V upon R1, that will be equal to 50 divided by 20. 50 divided by 20, that is equal to 2.5 ampere. So current I1 is equal to 2.5 ampere and I2 is equal to V upon R2. So current I2 is equal to 50 upon 40, that is equal to 1.25 ampere. Now we can calculate the power. So according to the formula, P is equal to IR square. This implies that P1 is equal to I1 square multiplied by R1, that is equal to 2.5 whole square multiplied by 20. 2.5 square is 6.25. 6.25 multiplied by 20. So power P1 is equal to 125 volt. Now we can calculate the power P2. P2 is equal to I2 square R2. Then taking the square 1.25 square multiplied by 40. 1.25 square is equal to 1.5625 multiplied by 40. So power P2 is equal to 62.5 volt. Now we will move the question number 7. In numerical problem question number 7, given statement is that two resistors of 4 kilo ohm and 6 kilo ohm are connecting in parallel. A 10 volt battery is connecting across the end. Find the value of following quantities. Here, equivalent resistance of parallel combination, current passing through each resistance, and potential difference across each capacitor. So, first of all, write the given data. According to the given data, we can write also repeat this question in a resistor or connecting with the series combination. So first of all, we find that R1 is equal to 4 kilo ohm. So 1 kilo is equal to 10 raised to power 3. So R1 is equal to 4 multiplied by 10 raised to power 3 ohm, and R2 is equal to 6 kilo ohm, that is equal to 6 multiplied by 10 raised to power 3 ohm. Now to find that if the voltage is 10 volt, we can calculate the value to find that R equivalent and current I1 and voltage V. So according to the statement, we can using the formula resistance of parallel combination 1 upon R equivalent is equal to 1 upon R1 plus 1 upon R2, and voltage V is equal to IR according to the Ohm's law, and in a combination of parallel V is equal to V1 is equal to V2. Now we can using the formula and find the solution. In given condition, we write that the solution is parallel combination. Find first of all equivalent resistance. 1 upon R equivalent is equal to 1 upon R1 plus 1 upon R2. So that is equal to 1 upon 4 plus 1 upon 6 is equal to 3 plus 2, that is divided by 12. So LCM is 12. So 1 upon R equivalent is equal to 5 divided by 12. Taking the reciprocal on both sides, now we have R equivalent is equal to 12 divided by 5. So R equivalent is equal to 2.4 kilo ohms. That is equal to 2.4 multiplied by 10 raised to power 3 ohm. Now we can calculate the current. According to Ohm's law, V is equal to IR. This implies that I1 is equal to V1 over R1. Here in a parallel combination, voltage will be same. So V is equal to V1 is equal to V2. So this implies that I1 is equal to V upon R1. That is equal to 10 divided by 4 multiplied by 10 raised to power 3. 10 divided by 4 multiplied by 10 raised to power 3. This implies that I1 is equal to 2.5 multiplied by 10 raised to power minus 3 ampere. So I1 is equal to 2.5 milliampere. Now we can calculate the current I2. According to the Ohm's law, V is equal to IR2. This implies that I2 is also equal to V2 upon R2. In parallel combination, voltage will be same. So I2 is equal to V upon R2. Putting the values, 10 divided by 6 multiplied by 10 raised to power 3. 10 divided by 6 is equal to 1.67 multiplied by 10 raised to power minus 3 ampere. This implies that I2 is equal to 1.67 milliampere. Now we can find the potential difference, as we know that in a parallel combination, the voltage across a resistance will be same. So V1 is equal to V2 is equal to V. So voltage in a parallel combination always same, that is 10 volt. Now we will move the question number 8. In numerical problem question number 8, given statement is that a house is installed with number 1 30 LED bulb of 12 watt, each of which are used 10 hours daily, and in a B part 5 fans of 50 volt, each of fan running 18 hours daily, and in a C part the number of electric units used, total energy consumed in kilowatt hour for a month of these devices. If PKR, its mean RS in Pakistani rupees, 15 is the rate of electric unit. So find the monthly expenditure of electric in 1 month is equal to 30 days. First of all, according to the given statement, write the given data. Now, given data is given that number of bulb is equal to 30, power of bulb is equal to 12 watt, and number of total power of bulb is equal to 12 multiplied by 30, that will be equal to 360 volt, and time t is equal to 10, or so in a 1 month that will be time t is equal to 10 multiplied by 30 is equal to 300 hours. Now in A part, number of bulb is 30 and power is 12 watt. So first of all, calculate the power of bulb. Power of bulb is equal to watt multiplied by number of bulb. That is equal to 12 multiplied by 30 is equal to 360 watt. And time daily uses 10 hours, and in a 1 month that will be equal to 30 days, so time t is equal to 300 hours. Now in a B part, number of fan is 5 and power of each fan is 50 watt. So the total power 5 multiplied by 50, that is equal to 250 watt. Now time of fan t is equal to 18 hour daily. In a 1 month 30 days, so 18 multiplied by 30, that is equal to 540 hours, and rate of each unit is 15 rupees. Now we can calculate the cost of bill. So to find that electric bill, now using the formula, bill is equal to power mean watt multiplied by time in hour multiplied by cost divided by 1000. We can calculate the electric bill. So first of all, calculate the bill is equal to power in watt multiplied by time in hour multiplied by cost divided by 1000. So we use the value of bill for a bulb 36 360 multiplied by 300 multiplied by 15 divided by 1000. So the bill of bulb is equal to 1620 rupees. Now we can calculate the bill of fan, that will be equal to bill is equal to 250 multiplied by 540 multiplied by 50 divided by 1000. So Bill of fan is 2,500 rupees. In other videos, we will meet with other interesting numericals and SLO based numericals. And also we can solve the KPK and Punjab book numericals. So like and subscribe our channel. Now we will have the total bill. Bill is equal to bill of bulb plus bill of fan, that is equal to 1620 plus 2025. So total bill is equal to 3645 rupees. Subscribe our channel and with the more videos. Best of luck.